Hi, this is the deep learning section of the Big Data Application Analytics course, E534. I'm Jeffrey Fox, your instructor, and this is a little section on self-driving cars, which has a lot of modern technology and and it's really founded on AI and, in fact, deep learning, because without that, you have no chance of a self-driving car. All right, here we are. Autonomous vehicles, which is self-driving cars are a particular example of. Okay, so here are some references. This is a very well-studied area. There's a huge amount of industry activity from technology companies, automobile companies, and in fact, other companies, the ride-hailing companies and things. This is meant to be the future of transportation. And there is here's some links. Here's a presentation from Princeton. NVIDIA has an open source example with a network and training data. And here is a tutorial, a couple of them. And these we have to address recognizing images and actually interpreting the images to decide what's going on, plan the path, detect the obstacles, read the road signs, even that's non-trivial, and most importantly, position the car where it actually moves forward and doesn't collide with anybody else. Not so trivial. Okay, here is the CNN in NVIDIA's example. Obviously, the real CNN is much more sophisticated. There are 3 cameras for this system, and we're basically trying to adjust the steering wheel based on the cameras so the thing goes straight down the middle and presumably doesn't hit anything. And it's quite a reasonably non-trivial network, starting off at the bottom with 3 66 by 200 pixel images. Actually, many self-driving cars have much higher resolution images. And then it whips through a set of convolutional layers, extracting features, and then it finally classifies and gets you the output with a set of fully connected layers. Here is the logical diagram corresponding to that CNN. We again have the 3 cameras, and at the top we train. Here's training, and at the bottom we just use the trained data to automatically adjust the steering wheel based on the center camera. All right, and of course, one reason you have such a lot of data is you just drive the car with a real driver and you just collect that data. And hopefully the real driver, on the average, does the right thing. And so you just get an enormous amount of correct data. You could also actually build simulations which drove correctly, because you can make certain the car drove down the center of the road and avoided in some optimal fashion any obstacle. So this is, unlike some cases, not a case where you really want unsupervised learning. You want supervised learning because you know the answer. We want no collisions. We want to get to the final place as quickly as possible. Here is lane and other vehicle detection. Here it's found another car, and here it's actually highlighted the lanes. Here it's detecting road signs. Here's the actual thing to look at. And this is presumably in China, and here's what it's identified as the things to try to interpret, including the speed limit, which of course, in even today's systems, the speed limit isn't always read. Like in my Tesla, it doesn't read the speed limit because it's afraid it's a road sign. It's a road number. And it isn't actually so trivial to find out what's a speed limit and what's a road sign. You travel on US 66. Well, the only reason you think it's US 66, not 66 miles an hour, is that 66 miles an hour is not a very common speed limit, which actually you could teach a neural net quite easily. The 66 was not a speed limit, an allowed answer. Okay, here is sort of the plan for the self-driving cars from the Society of Automotive Engineers. And here we have levels 3, 4, and 5, where we have sort of pretty good automation with the human driver available to respond. Here we do well on good conditions, and here we do well level 5 under all conditions. I remember recently, a year or so ago, there was torrential rain. I can't imagine any self-driving car driving in that torrential rain. I'm not certain I should have driven in that potential torrential rain. Here is Gardner's projection on autonomous vehicles in the emerging technologies for 2019. Here we have level 5 coming up, the innovation trigger. Here we have flying autonomous vehicles, even slightly further behind. We have level 4, which is plunging down to the trough of disillusionment. It hasn't yet to reach the key point, which is here. And they think because they're orange, they reckon that all these steps, level 4 or level 5, will take at least 10 years. I'm not certain I think level 5 will take 10 years. It may not ever really exist properly, but probably it will, but it will be hard. Level 4, well, who knows? I think it depends on the quality of the sensors and the tremendous improvement of the software. We have to just see how it goes. Here is a sort of variant of this, which is pointing out that there are some niches, which is for the autonomous vehicle market, which is, here's one called non-emergency medical transportation, NEMT, which is seems a very well-known, important part of the healthcare system. Is actually covered by federal by insurance, and Uber and Lyft have NEMT solutions, and Ford also entering the field. And this, of course, is initially just for ordinary ride-hailing. So this particular slide set has a mixture of self-driving cars and futures of transportation. So what we have to realize is that the so-called legacy automakers, the GMs, Chryslers, Fords, Peugeot, Fiat, etc., BMW, Volkswagen, etc., they're in some trouble because the number of cars purchased is declining, and one major reason is actually ride-hailing. There's an expectation that many people will not buy cars. Today, most people drive cars because ride-hailing doesn't exist. If you, within 5 minutes, can get a drive by just calling up on your cell phone, then the case for a car is much less compelling. And so we need to really look at the whole future of the automobile industry. And AI is relevant both for replacing cars and for helping cars. They will decrease production costs by helping in the manufacturing. They will create new revenue streams by allowing cars to be used in ride-hailing. And they will also enable self-driving technology. And self-driving technology is meant to be $500 billion or whatever this number, $556 billion is by 2026, growing at 39% per year. Okay, here we put in pictures some of the remarks we've already made. Here is the value of AI in billions in 2025 in the various parts of the automotive production chain, manufacturing, procurement, sales and marketing, logistics management, and then research and development. Here we have the number of shipments of mainly semi, I'm sure, and fully autonomous vehicles. Then the expectation is for it to grow really quite steadily until for the next few years. Here is just the dominant, in terms of miles driven, player in the field, Waymo, with truly self-driving cars, not assisted self-driving like Tesla. And here is the failure rate per 1,000 miles, and here is the number of miles driven, which is over 1.26 million miles in 2018. Pretty large number. Quite impressive. And of course, every time they drive, they get more training data. So they really have, and I mean, there's no way anybody, very difficult to compete. I mean, probably Tesla has, just from the automation of their cars and the fact that they can beam back data from all their Teslas. They must have a lot of data as well. So here are some leaders in self-driving cars and AI. Waymo comes from Google. Everybody has slightly different sensor technology. Waymo's is 360 degrees, and it's so far done 10 million miles of testing. And Cruise belongs to GM. It was purchased in 2016, and they claim to have an autonomous ride-hailing service, but who knows whether that will happen. So they also have a relationship with Honda. They specifically have a relationship with GM as well. Companies, all these car companies either have to have their in-house effort or partner, because everybody knows that this is essential. So NVIDIA has focused on building, based on their GPU, a focused automobile system. Because automobiles have so much image processing and GPUs are so good at image processing, that's likely to be a very good market for NVIDIA, which might outlast the Bitcoin market and the scientific computing market. So here he says that 2025, NVIDIA estimates the automobile market for its chips will be $8 billion. So Waymo, actually in October of this year, it said that some safety drivers will be removed. But GM Cruise delayed the launch of that robo-taxi service, ride-hailing, for further testing. Uber had a fatal crash in 2018, and that stopped Uber's test in Arizona. And Morgan Stanley cut Waymo's valuation as part of Google, so its valuation is a bit artificial. But you can see that there's a lot of skepticism. Level 4 and level 5 are more than 10 years in Gardner, and here's Morgan Stanley getting a bit worried. And here's passengers carried, 6,300 for Waymo in third quarter 2019. It just overwhelms everybody else. But here is the distrust, not trust. And before the fatal crash, it went down to 63%, but now it's up at 71%, more or less flat. Now we come to a different segment, electrical power. It's sort of related because the Tesla is both. Everybody thinks the future of automobiles is self-driving electric cars. So, of which Tesla is probably the best example, and Waymo the best technology for self-driving. Tesla doesn't have to have the best technology for self-driving because it's mainly an electric car with high-quality driver assistance. And here is the number of electrical vehicles in millions. So by 2030, 130 million. That's quite a lot. And currently there are 4 million in 2017. And probably around 8 million in 2019, maybe 9. So it's growing pretty rapidly. Now, an interesting concept is e-trucks, which are electric trucks, not digital trucks. And the reason why e-trucks may be pretty interesting is that trucks are much more structured than cars. Cars have to go all over the place, whereas trucks go. And especially when you think about short haul and long haul. Long haul are really. And so if you think about the last mile separately, which is for trucks and cars, you can see that these trucks are likely to be most successful initially in the long haul, although there they all have the problem. There's going to need a giant battery. And here I have the main problem with my Tesla was the charging infrastructure. I went down to the southern Indiana, and there were no chargers in southern Indiana. There's no decent chargers. So it says here there are only 16,000. I'm surprised at this much, that there's over 10%. There's, what is it, 15% there's 15% the number of gas stations are electric stations. I doubt that. I don't believe that's true. Certainly not true in Indiana. If you look at the number of superchargers, it's 10 in Indiana. There must be more than 100 gas stations in Indiana. So, I mean, that's got to be, I think this is pretty suspicious statistic. Unless you call a level 2 EV charger one that takes a day to charge a car, which is not terribly interesting. So this points out that transportation is 28% of the greenhouse gas emissions. And yeah, that's right. Yes, I hope you. And here is the expectation of the rise in global electric trucks. In thousands, 31,000 in 2016, 332,000 in 2026. This up here points out that now is a time to change, because the current traditional truck infrastructure is getting a bit old. There's some reason to enhance it, to improve it, because of the stricter emission standards and things. And so I think the owners of trucks are looking for some revolutionary technology. All right. So as I said, batteries are really limiting heavy-duty trucks, and actually it's the opposite of what I said. Small-duty e-trucks will become for short distance. Well, that has to be driverless. So you can have electric trucks for short distances, because then you don't have a serious charging problem. And as it says here, medium-duty trucks are the most promising. Because they have realistic sized batteries, and the miles driven is 50 to 100 miles. Like my Tesla claims to have almost 300 miles range. So it's not impractical to build a electric truck with a 1 day's range. And electric trucks are particularly good for stop and go, because that's electric driving is more efficient under those circumstances. So Tesla has announced and actually shown an electric large-scale truck, and according to this, it's going to be at least $30,000 more than the current long-distance diesel trucks, which are $120,000. And the batteries will cost a lot, and they'll be heavy. And they say they must have better charging infrastructure. And according to McKinsey, that a supercharger like I use now will take 8 hours. That doesn't surprise me, to charge a heavy-duty truck. So just some very practical reasons about battery size and charging time sort of constrains the industry to a particular solution. Here is a nice picture from Business Insider, North American Council for Freight Efficiency, and this tells you the parity, when everything will be equal, and when the cost. Electric trucks will be more expensive upfront than ordinary trucks for a long time, reaching parity for medium duty in 2030. For operating costs, you can see actually they're actually competitive with ordinary trucks, except for range. And it will be, according to this, 2030 before the ranges are competitive. 2025 before big trucks are competitive in operating costs. That's not so long. And same for daily range. So sort of this is really an important point, because or maybe this one as well. So it says in the next 5 to 10 years, we can see the entire fleet of diesel trucks replaced by electric trucks. With added up, because the upfront cost is probably easily got back by better operating environments. All right, so as I pointed out, global auto demand is falling, and that says the whole model of an automobile company is at risk. And so it's meant everything, demand is meant to fall 3% year over year. And then we have this interesting concept of a mobility company. So the business is no longer automobiles, it's mobility, which is, I think, sensible, because that's what we're using a car for. And here we have this interesting statistic I alluded to. 43% of auto industry executives said that half of today's owners won't want a car in 2025. Well, that's amazing statistics. Well, it comes from KPMG, but 43% believe that remark. And so that means that automakers have to become mobility service companies, and as we know, is really hard for companies to change. That's why old computer companies disappear, and we can see retail stores disappearing. And here we have by 2030, the ride-hailing market will be up 8-fold from 2017 at 285 billion. And we have here these two threats. Initially, ride-hailing, ordinary, then self-driving ride-hailing, and then autonomous vehicle. And they think that in 5 to 10 years, a quarter of the developed world will be using ride-hailing rather than personal cars. And in fact, it says that because people won't drive anymore, you won't have the drivers for ride-hailing, so you better have autonomous ride-hailing. So we need to have this pretty important concept that automobile companies must become mobility companies. And here we have the autonomous taxi market is $2 trillion a year in 2030. Pretty impressive. Here is some more charts. The electric vehicle investments, Volkswagen is largest. Here's Tesla. Well, Tesla's smallest, but it's the most successful. That's because it's not carrying this baggage of ordinary cars around. It's just got one product, an electric car. Here's the ride-hailing share. Uber. So Uber's this one is Uber. The dark blue is Uber. The light blue is Lyft, about half, and then a tiny amount of other. Here is preferred mode of transportation and commuting, personal car. This is today 82% personal car, expected to become about half. Ride-hailing is meant to go up to 27%. And things like public transport might increase. I'm not so certain about that. People have been trying to make it increase for a long time. I think ride-hailing has some big advantages over public transport because it's got this smaller unit called the car. You can transport dynamically people on demand in a much more efficient fashion. Here's the number of cars on the road, and it's actually meant to, even by 2030, actually decline to 262 million in the US. It's certainly not growing very fast here. So, and here is a final chart on this page. Here is Ford approach to self-driving business, where this is their view of what they have to do. Trouble is that people in the company probably aren't trained to do any of these things, which is why actually you have startups and people like you listening to this course. You should be moving in because the role for entrepreneurs, giant businesses are collapsing. We have the retail business collapsing, the automobile business collapsing, healthcare is collapsing. They're all collapsing because of technology change. And the older companies can't change fast enough. And the smaller companies, well, we'll also see banking changing. I mean, that's really amazing. It's really striking. Here are a summary of some of the companies. Well, we know about Uber, and it has e-bikes, which are quite popular, of course. Uber Eats, and it's actually not increasing a lot. It's basic ride-hailing. It's, however, getting more profitable. Here we have Lyft with 20 million active riders. Is not as broad a global scope as Uber. And we saw on the previous slide, it's somewhat less than half of Uber in the US. Didi is very powerful in China. It actually, Uber gave in and sold it, whatever it had in China, to Didi. Grab in Malaysia is 100 million users. Bolt is, which used to be called Taxify, is the second largest behind Uber in Europe. And here just are some numbers with market caps. General Motors, 49 billion, Ford, 35 billion, Tesla, 42, is between Ford and GM. Uber, 51, bigger than GM. Lyft is smaller, it's 12, because Amazon is 850 and Microsoft $1 billion. Didi's estimated is 50 billion, but it's actually not listed on the stock market, so you can't find its actual value. But it's important to realize that that at least the people in Wall Street thinks these ride-hailing companies are as important and as promising as traditional companies. And it's expected that ride-hailing is like this and traditional companies are like that. Not because It's because they can't change. Poor old GM has to spend all this time worrying about Buick and Pontiac and Chevrolet and keeping those brands alive. They need to just toss the lot and go for the jugular of the future. But they can't do that. That's why small companies will win. Drones. Let's have a little bit about drones and drone delivery, which is actually, when I was writing these slides on October 18, the Wing, which is a part of Google, it delivered its first made its first delivery in Virginia, and it has a license to do that. And this was a collaboration with FedEx, Walgreens, and some local Virginia retailer. And this is just a press release, and it's worth noticing that medical deliveries are likely to get approval first, because the value add of a fast delivery is particularly important. If you're trying to deliver clothes and things like that, maybe they're not so important, so it's difficult to argue for that. But medicine is both small, high value, and that's what are best for drones initially. Here's the last slide, which is about drone delivery, and it has some pictures here. Notice actually some of these drones have different delivery models. Some land, some drop, and so they have, you can see they have very different blade things. This has 4, this is a whole string of much smaller ones. This is Google's, this is UPS's. And here is the value in billions, 54 billion today, going up a factor of 10 by 2026. So these are all big numbers. And and we have now quite a few players. So here we again look at changes. UPS and FedEx have to change. And they both are trying to change, and putting drones in their part of their fleet of delivery is an important part of that change. All right, that's the end of this section on the future of the automobile industry, which we should say is the future of mobility companies, because there will not be an automobile industry 10 years from now. All right, thank you very much. Good.